Hi, I'm Frank Schallenberger. I'm a medical doctor. I head up the Nevada Center for Alternative and Anti-Aging Medicine in Carson City, Nevada. And I've been practicing medicine for going on 40 years now. Most of that time, in excess of 30 years, I've devoted to the study of alternative medicine. You can also hear that referred to as integrative medicine or biological medicine or natural medicine. Basically, it's when doctors focus on helping the patient's innate healing tendencies in the patient's body to heal the body itself. The Creator, when He created our bodies, did it with a divine plan that allows our bodies to heal themselves. In other words, our bodies are able to diagnose whatever condition, whatever disease, whatever ailment is affecting us, and to create conditions in the body wherein the body will actually, literally heal itself of that disease or condition. And what we as natural alternative physicians do is work with the patient's body to find out exactly what we need to do to help that body heal itself. Of all the things that I can do to help my patients' bodies heal themselves, singularly, by far, the most important is to improve the way their bodies produce energy. And so we produced this four-part video lecture series that is going to go into exactly that. How your body produces energy, how that affects your health, how it can make you sick when you don't produce energy adequately, how it will make you well when you do produce energy adequately, what you can do to maximize your energy production, and very importantly, how you can in fact measure your energy production so you can know if you've got a problem in this regard long before it actually happens. So the title of this series is Health, Aging, and Disease. It's all about energy. And this is part one, the importance of cellular energy production. This is the bullets on the four-part series that we're going to do. Part two is maximizing your cellular energy production. Part three is measuring cellular energy production with bioenergy testing. This is a testing device that I developed a few years ago. And part four is how to use biological or bioenergy testing to maximize your health and to slow down aging. This lecture series, is going to be devoted mostly to professionals. We're going to get into a little chemistry. However, I found over the years that the way I present this information is typically handled very well by lay people as well. So I think all people will see some benefit out of this. That certainly is my hope. I have written two books which are currently available at all the major book outlets. One's called Bursting with Energy, and the other's called The Type 2 Diabetes Breakthrough. They're both about energy production. Diabetes would be an example, a great example of a chronic disease that is 100% caused by decrease in energy production and is 100% prevented and healed by improving energy production. So that's why I wrote that book. But you can get the gist and a lot of particulars and all the references that you're going to hear on this lecture series in those books. So let's start off and let's just look at something that is very basic, and that is that energy production is at the center of literally everything that happens in your body. Energy production is by far and away the most critical. If you stop drinking water, you'll do all right for a while. If you stop eating, you'll do all right for a while. If you stop bathing, you might not smell too good, but you'll do all right for a while. But if you stop producing energy, you will die in 2 to 3 minutes. That's how fundamental energy production is to your health. And what this slide shows is that everything is dependent on energy. Whether it's the function, every one of your organs depends on energy production to work. Even your senses, your repair system, so that if you break your leg or you injure a part of your body, your ability to repair it, 100% dependent on your energy systems. Even your thoughts, so conditions say as depression, especially attention deficit disease, bipolar disorders, all those kinds of conditions of thoughts or conditions primarily of energy deficiency. The ability for the body to digest. How about elimination and detoxification? All the toxins that you get exposed to are only eliminated one way, and that is through energy production. And we'll look into more about how all these things are factors here in the next few parts of this lecture series. But just to understand that energy production is at the center of everything. There is nothing that your body does. It isn't 100% dependent on energy. You can't say that about any vitamin. You can't say that about any food. You can't even say that about any hormone. And that's why it's so critically important. So what is health? Well, a lot of people think that health is just the absence of symptoms. I feel good, so I must be healthy. Or a lot of other people say, you know, I went to my doctor, he told me I didn't have a disease, so I must be healthy. Or he did a bunch of tests on me, my cholesterol and my blood sugar, and all my tests are normal, so I must be healthy. But the truth is, health is not the absence of anything. It doesn't mean just because you don't have abnormal tests or just because you don't have symptoms, you're not really healthy. Health is not the absence of anything. It's the presence of something. And that something is energy. And you're as healthy as the amount of energy you can produce. If you can produce optimal amounts of energy, then I would call you optimally healthy. If you can produce suboptimal amounts of energy, then that's about how good your health is too. How do you know if you're healthy then? If you can't tell by just an absence of symptoms or normal blood tests, how do you know? Well, health is the presence of optimal cellular energy production. And the reason that is because there's one thing we've just said, is that every biochemical and physiological reaction is dependent on cellular energy production, making it the most global biomarker for health. There's nothing that is singularly as dependent on the way your body functions as how well it produces energy. So it's the most global biomarker for health. Also, cellular energy production is affected by everything else. So energy production is affected by everything that goes on in your body, from stress to how you eat. And everything that goes on in your body is affected by cellular energy production. So health and cellular energy production are basically one and the same thing. And finally, decreased cellular energy production occurs long before any sign or symptom of a disease. And that's what we're going to go over today in just a few minutes. And I'm going to show you that just because you don't have any symptoms, just because you feel well, just because your doctor told you your lab tests were within normal limits, doesn't mean that you're producing energy on a cellular basis as well as you could be. And that's what's necessary to prevent disease, maximize your health, and even slow down the aging process. So what are diseases then? So you probably figured this out by now. Diseases, according to the dictionary, are just the names that are given to various pathological conditions in the body, in which the organs or the regulating systems of the body become dysfunctional or don't work. The pathology of all chronic degenerative disease, the thing that causes all those diseases to happen is the direct result of free radical injury. Most of you have heard of free radicals. They're special molecules that are produced during energy production that actually end up destroying the body. So that's how we get these diseases, through free radical production. And what I want you to understand right from the get-go is that free radical production is caused by only one thing, and that is impaired cellular energy production. So if you are optimally producing energy in your cells, you will be producing the minimal amounts of free radicals that your body requires. But to the degree that your cells are not optimally producing energy, you're going to be producing many more free radicals than you should be ideally, and that's what's going to cause your body to ultimately break down and for you to get sick. So health, it's the presence of cellular energy production. Disease, it's the consequence of not having adequate cellular energy production. So, you know, during the course of this lecture series, I'll use a number of terms. They all really refer to the same thing. Cellular energy production, that's the amount of energy produced in the cells, is produced in a part of the cells called the mitochondria. So every cell has thousands of mitochondria. They're little areas in the cell where oxygen is processed into energy. And we're going to go over all of this in the lectures to come. So cellular energy production is really the same as mitochondrial function, which is the same as mitochondrial efficiency, which is the same as oxidation efficiency, which is the same as oxidation potential. So these are all terms that scientists and doctors use, all referring to the same basic thing, which, and for the most part, I'll be referring to in this series as cellular energy production. So that's the little mitochondria. That's an example of the mitochondria. And we won't spend much time here. Probably you're thinking that's a good thing. But this just shows you, this slide shows you that today's scientists are able to map out what goes on in the mitochondria to a very, very detailed extent. And these show the various biochemical processes that go on. And fundamentally, what I can tell you is right over here is oxygen, and right over here is water. And what's happening in this mitochondria is that oxygen, which is one of the highest, most energy-dense molecules in the universe, is converted into water, which is the lowest energy molecule in the universe. So you got high energy molecule converted to low energy molecule. The result is a release in energy. And it's through this complex system in the mitochondria here that your body is able to harness that energy and then use it in the cell for the cell to do every single one of the things that the cell can do. As long as your mitochondria can effectively process this oxygen, you're going to be producing lots of energy. You're going to be producing it efficiently. Your cells will work well. You'll be at optimal health. But as soon as that mitochondria can't produce energy from that oxygen efficiently, what's going to happen is excessive production of free radicals and destruction of your tissues, and of course decreased energy production. And along with that comes decreased efficiency. Next few slides are going to kind of go into some of the scientific literature. I'll probably go through these kind of fast, but these are all available, you know, through any library or through PubMed. You can get all this information. This particular slide comes from a friend of mine. His name is Warren Deed, who wrote one of the premier books on aging and degenerative disease. And what Ward pointed out is that nothing is as consistent, as predictable as the gradual linear decline in mitochondrial function that we see in all aging populations. So here's a 30-year-old person. We typically look at 30 years old as being the age at which your cells are able to produce energy with maximum efficiency. And this is what happens as you get older. And if you come down here to around the 70-year-old person, you can see that roughly speaking, the energy production is cut in half of what they were in the prime of their life. So what we would like to do, and what's possible and what you're going to learn in this lecture series, is how to flatten this curve out so that instead of energy production going down in a very linear and predictable way, it stays pretty much flat. Now, is that possible? Yes, it's definitely possible. How do I know? Because for the last 10 years, I've been measuring energy production. We have a system, and you're going to learn about this, a way to measure cellular energy production in my patients. And I can tell you, I have a lot of patients. In fact, I have one gentleman who's 80 years old, and instead of his energy production being up here, his energy production is right here around the lines of a typical 40-year-old man. So it's right up in here someplace. I'm 62 years old. That would put me right here. But my energy production is as good as the average 30 years old, so my energy production's up there. We'll talk about how you can do that for yourself. These are just some articles, some premier articles that have been published. This one from the Proceedings in the National Academy in 1998. Again, the same Proceedings in the National Academy in 2002. What these articles basically say is impaired mitochondrial function plays the major role in the entire aging process. So if you want to age gracefully, if you want to have full function as you get older, what you want to do is keep your cellular energy production at a maximum. Down here it says cellular processes affected by impaired cellular energy production include, name something basically, and this is kind of reminiscent of the first slide we saw, your ability to detoxify, to repair, to replicate your DNA, to maintain the balance of water in your body, and all the higher order processes such as cognitive function, the way your brain works, all of these things are dependent on energy production. Now, this is a slide that is just fantastic to me. This comes out of a magazine called Nature. This was published in 2004, and this definitely proves my point. And so what they did here in this slide is the scientists genetically modified some mice. And they took the mice and divided them in two groups. Half the group, they modified these mice so that their cells could not produce energy as efficiently as the other half. And then they just watched what happened as these mice lived out their life. Well, predictably, the mice that couldn't produce cellular energy as well had a significantly reduced lifespan. They also had a premature onset of all the age-related phenotypes. That means all the stuff that happens to us as we get older that we don't like, such as loss of lean body mass. Alopecia means hair falling out. Kyphosis means osteoporosis and bending over, all that stuff that we see with older people. Anemia, reduced fertility, heart failure, all the things that you would expect to see in somebody as they age were dramatically increased in these mice because they couldn't produce cellular energy efficiently. Same thing happens to us. And the authors concluded on the bottom here, these results provide a causative link between decreased mitochondrial function and aging. Basically, they're telling you this is what causes your body to age. Now, there's another study that was very similar to that and kind of looks at it a different way. But again, this study also came out in 2004 in a magazine called The Aging Cell. And what these scientists did is they didn't genetically modify anything. They just took a bunch of mice. And they used a technology, it's not the same as the one I use, but a different kind of technology to determine how the cellular energy production was in these mice. And what they noted was that some mice produce cellular energy production very efficiently. In our today's terminology, we would call them fast oxidizers. And somewhere in part 3, I'm going to go over the whole concept of fast and slow oxidizers with you. But some of these mice were what we call fast oxidizers, meaning they produced energy very efficiently. And some of the mice were on the other end of the spectrum, and we call them slow oxidizers, where they did not produce cellular energy as efficiently. And what they did is they just followed them over the course of a lifetime. And the results were extremely dramatic and established an association between longevity and individual variations in energy production. Because what they found was that the mice that in the higher quartile of mitochondrial function, in other words, the mice that were in the quarter of the mice that produced the most resting energy, cellular energy production, lived a full 30% longer than the mice in the lowest quartile. Now that's astounding. Almost 40% longer simply from one thing, and that is improved resting cellular energy production. As you will see in the rest of this lecture series, we can measure that. So we can tell you what quartile you're in. If you're in the lowest quartile, we can then tell you how to move yourself up in the world. We're going to talk a little bit, I think it's in the second part of this lecture series, on how cells actually create the free radicals. I alluded to that a little bit, but how cells create the free radicals that cause our bodies to age. But I did want to mention this study that was published in 1994, again from the Proceedings of the National Academy of Sciences. And in this study, I'll just quote the authors, say, oxidants generated by mitochondria appear to be the major source of oxidative lesions that accumulate with age. So that's where you're getting all those free radicals, is from the mitochondria. And then they go on. These lesions that cause the aging process, related deficits in the mitochondrial function, which are associated with the general physiological decline known as aging. Basically, what they're telling you right there is that the reason we age and will age is because we'll produce free radicals, and the more efficiently our mitochondria process oxygen to produce energy, the less free radicals we'll produce, the longer we'll live, and the better our quality of life. Now, I'm going to really scoot over these next few studies very quickly. I just wanted to prove a point, and that is if you go to any of the medical databases and you plug in decreased mitochondrial function or decreased cellular energy production and the name of a disease, just name any disease, you'll see that there's already many articles written about the association between mitochondrial function and those diseases. So I'm just going to run through these slides very quickly and just to kind of make a point. And this is only a small sampling of what's available out there. So here's one about mitochondrial function causing osteoporosis. Here's one about age-related macular degeneration being caused by decreased mitochondrial function. Here's one about blood pressure being caused by decreased mitochondrial function. This article here is about rheumatoid and all the reactive arthritises being caused by decreased mitochondrial function. This one here is about cancer being caused by decreased mitochondrial function. Actually, Warburg won the Nobel Prize in the 1930s for just that point, showing that cancer was a direct result of decreased mitochondrial function. And of course, diabetes, I alluded to that in my more recent book, is all about that. Also, Parkinson's disease, caused by decreased mitochondrial function, as is Alzheimer's disease, the same thing. Heart failure, there's a resurgence of heart failure these days. Nobody quite knows exactly why, but certainly you can bet that the primary lesion for the increase in heart failure has to do with decreased mitochondrial function or decreased cellular energy production. And this is all conditions of the heart, from coronary artery disease to arrhythmias, all of this primarily caused by decreased mitochondrial function. And there are many more articles exactly like that that would go on to say the same thing about any disease you can name. Now, before we get into the next topic, I just want to be clear on one thing that's often misunderstood. I've been using the term cellular energy production, and that's the way your cells produce energy. But I want you to know that that's different than feeling energetic. Feeling energetic is another issue entirely. So that you can have very poor cellular energy production and actually feel energetic. And conversely, you can have excellent cellular energy production and feel tired and run down. Let me give you an example of how that would work. Let's take a premier athlete. Let's take Lance Armstrong, for example. I've not tested Armstrong, but it would be pretty easy to say that his cellular energy production is at an all-time high. And yet, if he didn't get enough sleep, if he was overly stressed, if he overtrained, he may very likely be complaining of fatigue and tiredness and weariness. On the other end of the spectrum, we see a lot of people who have very poor cellular energy production, but can have decent energy levels. I mean, they feel pretty good. So there are two different topics and two different things. And yes, it's true. If you have poor cellular energy production, ultimately it will lead to you feeling tired and run down. But there can be a long period of time where you actually feel quite good. And that's what takes us into this next concept, which is the concept of early onset mitochondrial dysfunction. This is a term that I developed, and we just abbreviate it, so I have to say all that long phrase, EOMD. EOMD stands for early onset mitochondrial dysfunction. And what it means is very simple, actually. It refers to a deterioration of the mitochondrial function or a deterioration of cellular energy production that commonly occurs in the young and asymptomatic and increases with age. So it can start early and it gets worse as you age. This is the name of the condition. So we're, again, to reiterate, we're talking about a condition where the mitochondria are not producing energy well, with decreased cellular energy production, and this can occur in the young, so it's early onset. So let's just ask this question. Is a person healthy, or are they just not sick? I'm here to tell you EOMD is for real. Here's a study that we published a few years back where we took 50 subjects. Now these subjects were randomly selected as they presented to a number of different clinics. These subjects were between the ages of 20 and 40 years old. So they're young. They were asymptomatic, which means that they weren't complaining of anything. They felt great. They were health conscious because the only reason they showed up to have their cellular energy production tested was because they were health conscious. They wanted to make sure their cellular energy production was good. And these were a group of young people from all over the world, namely from clinics in Carson City, Los Angeles, Grand Junction, Colorado, and Singapore. And here's what we found out in these 50 subjects. 54% of them had normal mitochondrial function. So that's what you'd expect, right? You expect young people who feel great should have normal cellular energy output. But that was only 54% of them. All the rest had decreased cellular energy production. And I find that amazing. We're talking about healthy, health-conscious, these are exercisers, by the way, young people, and almost half of them are already showing that their ability to produce energy on a cellular level is starting to become compromised. But let's break it down, because it even gets worse. When we broke it down, broke that 46% down to see, how bad do they get, in fact. 36% of them had less than 90% of what would have been predicted, or what would have been considered a normal cellular energy production. 26% of them had less than 80% of what they should have had. 12% of them, 12 out of every 100 young people who feel great, had less than 60%, almost half of what they should have been coming up with. So these people, all of these people here, have what I call early onset mitochondrial dysfunction, EOMD. Now, the last thing on here to notice is going to turn out to be very important. Because of all the subjects that had normal, healthy cellular energy production, none of them had impaired fat metabolism. On the other hand, every single one of the young people who had a deficit in their cellular energy production, every single one had an impairment of their fat metabolism. We're going to talk very much about that because this is critical to understanding how things go wrong, how things went wrong with these young people, and how things can go wrong with you and I. So, early onset mitochondrial dysfunction, decrease in cellular energy production in the young and the asymptomatic, it happens. And it not only happens, but it's very common. And it doesn't give you any warning system, and it's going on right now, and a lot of you people that are listening to me talk right now, and you'd have no idea it's going on if you weren't able to test it. And fortunately, we are able to test it, and we'll be talking about how that testing process happens in some of the later lectures. So what's the cost of having that problem? What's the cost of having EOMD? Here's just a partial list. This just comes from the literature. You don't synthesize your DNA and RNA as well. You don't synthesize protein, enzymes, and hormones as well. You can't maintain your cell membrane potential. This turns out to be a big problem. You have accelerated cell death and cell loss. You're aging faster. You have decreased intracellular hydration. Your skin and the rest of your body tends to become dehydrated. You have increased free radical damage. We already mentioned that. Your brain isn't going to work as well as it should work. You have decreased ability to throw off toxins. This is huge because we live in a world that's just filled with toxins. And if our ability to remove toxins from the body is compromised in any way, shape, or form, this can dramatically lead to illness. And finally, you have a condition called mitochondrial decay. Mitochondrial decay is different than EOMD. EOMD just means that the mitochondria aren't working that well. Mitochondrial decay means they're dead. They've been destroyed. So all of that, aging and degenerative disease, these are all what EOMD leads to. So yes, it's important to be able to diagnose that and to find out how to treat that. I just mentioned this concept of mitochondrial decay, and so I'll kind of go over a little bit about, again, what the main difference is. EOMD just refers to deterioration in the mitochondrial function. Mitochondria produce a molecule called ATP, and EOMD means they don't do that very well. Whereas mitochondrial decay means that the mitochondria have actually been destroyed. EOMD is reversible. They can be fixed, whereas mitochondrial decay can't. Once your mitochondria are destroyed, you're not getting them back, at least not so far with what we know. EOMD occurs in young and healthy people, but you're not going to see mitochondrial decay in young and healthy people. That's something that comes along around the 6th or 7th decade. But it starts with EOMD. EOMD leads to mitochondrial decay. And so the idea is, don't wait until you actually get mitochondrial decay to think, geez, maybe I better start doing something about my energy production. Find out about it early before it leads to mitochondrial decay, because EOMD is what causes it, and by diagnosing and treating EOMD, you can prevent mitochondrial decay and the disease and the increase in the aging process that it leads to. We're going to go into this in greater detail in the 3rd lecture, where we talk about what to do about all this stuff. But there are 10 causes of EOMD that I've been able to identify. Let's just take a look at them. Some of these are causes that happen before the oxygen actually gets to the mitochondria. These are factors that have to do with not the actual mitochondrial function itself, and these are factors that have to do with how the actual mitochondria are functioning. You can kind of think of you can kind of think of the mitochondria as sort of being a factory, okay? So there can be problems in the factory, or there can be problems with delivery of things to the factory. If you've got a factory that's making shoes, and there's something wrong with the shoemaking machine, well, then there's something wrong with the factory itself. But if you've got a factory that makes shoes, but the trucks that deliver the leather aren't getting there on time, then that would be a pre-factory problem. So that's kind of how you want to think about these things. But pre-mitochondrial problems can be decreased lipolysis. That means decreased breaking down of fat. This is very common. Hypoglycemia means low blood sugar. You need sugar to produce energy optimally. So if your blood sugar is low, can't do it. Ischemia means a decrease in blood flow. This is the kind of thing that would happen when your circulation is impaired. Very, very common in the over 50 age group. Hypoxia refers to not getting enough oxygen in your bloodstream. This can be obvious from smoking cigarettes. It's a main way to get hypoxia. Other ways to get hypoxia would be if you had a condition like asthma, if you have any other condition of the lungs, allergies, things like that can lead to hypoxia. Carbon monoxide toxicity, which is not that uncommon in today's modern buildings, can lead to hypoxia. Decreased methylation. I will talk about the methylation process in lecture 4. It's a somewhat complex biochemical process, but I think every doctor and patient should really have an idea of what methylation is. And inflammation. Inflammation is a huge topic. Inflammation will generally decrease the ability of the mitochondria to get the substrates that they need to produce cellular energy production efficiently. And then finally, it's the mitochondria themselves. Mitochondria can become toxic, especially heavy metals like lead and cadmium and mercury can be very toxic to mitochondria. Stress. I'll tell you about the case of a remarkable woman who's 64 years old and the impact of stress on her cellular energy production. Nutritional deficiencies, this is where your B vitamins in particular, especially magnesium, other enzyme deficiencies, this is where they act. Hormonal deficiencies are a huge problem, especially as people get older. They can impact on the way mitochondria work. Mitochondria need certain hormones to function. If they don't get those hormones, they will not work efficiently. And finally, decreased fitness. So fitness is an important aspect of keeping your mitochondria up and running. So these are sort of the 10 causes on how people do develop early onset mitochondrial dysfunction. In those young people I was telling you about, almost all of them, the cause was low blood sugar. Because they just ate very poorly and they didn't get enough sleep. But these, overall, when I'm measuring my patient's cellular energy production and it's bad, I'm going to look for these kinds of causes to start helping them improve. Now, diagnosing EOMD is important. By now, you've probably started to figure that out. But here's why. This is a little reiteration. Because through the combined action of increased free radical formation and decreased antioxidant buffering, EOMD is the primary cause of all of this: mitochondrial decay, aging, and degenerative disease. So if you don't want to have that, you don't want to have aging, you don't want to have mitochondrial decay, and you want to get diseased, don't get EOMD, because that's what causes it. Now let's see how it does that. Let's skip right over to this slide. It does it by a combination of two factors which work together. So up here I've listed many of the causative factors that we just talked about. Decreased fat metabolism, ischemia, hypoxia, etc. All that stuff is right up here. Okay? That leads to decreased mitochondrial function, EOMD, right in here, okay? Now when the mitochondria don't work so well, remember, you get increased free radical formation. But the other side effect of this is that you get decreased free radical buffering enzymes. So let me explain this. When your body makes free radicals, and it will do that, healthy bodies make free radicals. I'm making free radicals right now as I talk to you. When the body makes free radicals, it's not a big problem. Like I say, our Creator took care of all of this stuff. And He made sure that not only do we make free radicals, but we also make special enzymes that contain those free radicals so they can't hurt us. These enzyme systems are called free radical or antioxidant buffering systems. You might have heard of some of them, like catalase is one, superoxide dismutase is one, glutathione peroxidase. These are all buffering enzymes. What these enzymes are able to do is run around, find the free radical, grab it, and neutralize it before it can do any harm. And however, you got to remember now that these free radical buffering enzymes, they're all made from energy. So you can't make these enzymes if you don't have adequate amounts of cellular energy production. So think of it. When you have decreased cellular energy production, you get a double whammy. On the one side, you're producing more and more free radicals because the mitochondria are inefficient. On the other side, because you don't have enough energy production, you can't produce enough of the antioxidant enzyme systems that quelch those free radicals. You got too many of the bad guys, not enough of the good guys. That's a double whammy. And what that leads to is the mitochondria actually become destroyed over time. It can take decades, but they'll become destroyed. A cell that used to have 3,000 mitochondria might have 2,000 by the time that person reaches age 55. And of course, as the mitochondria are destroyed, that decreases the cellular energy production even more. And it's just a vicious cycle. And so for decades, starting in your 30s, and working through your 40s and 50s, this is sort of the vicious cycle that's going round and round in your cells. Decreased cellular energy production, increased free radicals, decreased ability to quelch those free radicals, increased mitochondrial decay and aging, and ultimately the whole system breaks down by the time you're 60, 70. You start to actually see breaking down of the body, we call that aging, and degenerative disease, all those diseases that old people get, but young people don't get. We call that degenerative disease. That's how it starts. So now you have a sense for why it's important to know about your cellular energy production. So in summary, oxygen is converted to water plus energy through the process of cellular energy production. Free radical damage occurs to the mitochondria and inevitably occurs as a result of this process. So as you're doing that, you're going to get some free radical damage. That's why we can't live forever. If we never had any free radical damage, theoretically, our bodies would never break down and we'd live forever. But that can't happen, and so ultimately we will die. The problem is because we're making these free radicals in excessively rapid fashion and in excessive amounts, and because at the same time we're making too many of them, we're not making enough of the enzymes to control them, we're aging prematurely. We're aging at a much more rapid rate than we need to, and we're falling apart at much earlier ages than we need to. There's no reason, absolutely no reason on earth, why the average age of the American population could be 100, 110, and I'm talking a fully functional 100, 110. There's no reason. The only reason that we don't see that is because of this excessive free radical damage due to a decrease in cellular energy production. So oxygen is converted to water plus energy. As that happens, we get free radicals. This starts to destroy cells. The longer you're alive, the more damage you're going to get from that. And the less efficient the process of cellular energy production, the more and the faster that's going to happen. As that accumulated free radical damage continues to worsen, it leads to mitochondrial decay. mitochondrial decay is the central lesion. We've seen that. It's been published. We know this. In the entire aging process, in all degenerative disease. Aging and degenerative disease is determined by your starting point. Genetically speaking, how good were you at cellular energy production even when you were born? And how well are you taking care of it? How rapid has been your rate of EOMD? Mitochondrial decay is inevitable. Sooner or later you're going to get it and you're going to die. What's not inevitable is the rate at which that occurs. And the rate of mitochondrial decay is determined by one thing, and that is oxidation efficiency or cellular energy production. So if you want to slow down aging, if you're interested in not getting sick as you get older, if you're interested in feeling great and functioning, have full function as you get to be older, then what you want to do is concentrate on your cellular energy production. Now I'm going to go over a slide here that shows this thing in kind of a graphic process. It shows the stages of the aging process as it relates to cellular energy production. Here's a healthy person. This right here at maximum ATP, again, ATP is the energy molecule. So if this is the maximum ATP production, here's your healthy person. He's at the maximum. Now you can produce ATP, you can produce energy in two ways. You can produce it with oxygen, and you can produce it without oxygen. We know this because if you were to hold your breath, your oxygen levels would go down very quickly. You wouldn't die instantly, would you? You'd actually stay alive for a while. And the reason you'd stay alive is because your body has a way of producing energy even without oxygen. Now, it's not a very efficient way. It leads to a dramatic increase in free radical production, and ultimately you'll die. So you can't hold your breath forever. But you can hold your breath for a relatively decent amount of time before you do die. And that is because your body has the ability to produce energy, keep you alive at least for a little bit, without oxygen at all. And that's what this refers to on the slide, where it says anaerobic here. Your anaerobic production of energy, or ATP, is where you produce energy without oxygen. Now, these, where it shows glucose, which means sugar, and fat, the only way you can produce energy from glucose and fat is with oxygen. So in your healthy guy here, he can produce a lot of energy, that much energy, in his mitochondria, so that's maximum mitochondrial ATP or energy production right here. And then on top of that, he can produce some additional energy without the use of oxygen. You add all that up, his total energy production is right there. That's a healthy person. Let's see what happens to that person as he gets older. Because right in the middle here is the condition I was telling you about, EOMD. This is where he's asymptomatic. He may feel really great, or he may have what we call functional symptoms. Those would be symptoms sort of like tiredness, maybe headaches, maybe allergies, things that the doctor says, look, you know, they're nothing, you don't have a disease, there's nothing really wrong with you, it's just that your body's not working as well as you would like it to work. We call those functional symptoms. We hear those words if you're in my age bracket. If you're in your 60s and you complain to the doctor about something like that, he'll usually tell you something, well, that's okay, you're just healthy for your age. What all of that means is you're not healthy, but you're not sick and diseased. You're in this category, but you're moving that way is the point. So let's see, the very first thing that happens between the healthy guy and the guy that's not quite so healthy is the inability to burn fat efficiently. Notice that his total energy production from oxygen, his maximum mitochondrial production, his mitochondria are working just as well, but when they're working, they're relying much more on glucose and a lot less on fat. They can't burn fat as efficiently. We'll talk about why that is, but that's the very first phase that shows up as people move from healthy to not so healthy, is they don't burn fat efficiently. This leads to two things. One is they become overweight, start having more fat on their body. Two is, because they're burning more and more sugar, they start to get low blood sugar. Your body can't store a lot of sugar, so if you start burning it very rapidly, you're going to run out pretty quickly. And so they develop low blood sugar. So this is the thing that we normally see in the young people, and of course, as you get older, is a much higher incidence of this. As this continues, though, what's going to happen is this inability to produce energy well from fat is going to lead to a second phase, and that's the mitochondria themselves are going to start becoming very dysfunctional. they're not going to themselves work very well, such that the total mitochondrial production of energy now goes down. So it went down for the first time. Now, whereas they could produce energy at least pretty well from glucose, if not from fat here, now they can't produce energy well from glucose or fat. And they're relying more and more on their anaerobic energy production. Now notice that the total energy production is still the same. So they can still go out and do things. They can ride up the hill in their bicycle the same way they used to when they used to be this way. But they're not going to do it nearly as efficiently. They're going to be producing an abundance of free radicals. They're going to be damaging their body. They're probably not going to be able to go up the hill in the same time they used to. But again, these are, quote, healthy for your age people. They're asymptomatic. They just have early onset mitochondrial dysfunction. Eventually, however, the excessive free radical production from all of this leads to this, where now the mitochondria actually are starting to get destroyed. Maximum energy production for the first time goes down. Now they have mitochondrial decay, they have disease, and they're in an irreversible state here. Can they make this better? Yeah, they can move here. Can they go all the way from here to here? No, not with the technology we know today. So the idea is to have yourself tested, have your mitochondrial function tested. If you're already in the healthy column, fine, great. We'll show you some examples of this in the lectures to come of some real people that were like that. If you're not, then let's talk about what we need to do to move you in that direction so that you don't continue in this downhill course of decreased cellular energy production, decreased health, and increased aging and disease. So we've come up with something at the clinic that I call cellular medicine. So cellular medicine starts off with this kind of thinking. All disease and aging starts in the cell with decreased oxidation efficiency or decreased energy production. This decrease in oxidation efficiency begins in the 30s when people are asymptomatic, but they're not healthy. This leads to a decrease in organ function, which is the functional symptoms. They don't digest as well, they get heartburn, et cetera, et cetera. They don't really have a disease, they're just not working as well. And then finally, that ends in the frailty and the symptoms of the diseases of aging. So in my concept here with cellular energy, with cellular medicine, there's only one disease. We're simplifying this. And that disease is decreased cellular energy production. And there's only one treatment, which is maximizing cellular energy production. So that's why I say that of all the things that I've learned with my patients to help them, help their bodies to heal naturally and heal well, of all the things I can get them to do, improving their cellular energy production is the one that by far and away works the best. By the way, it's not just for the prevention of disease. We've talked here entirely about staying healthy and preventing disease, but it's also critical for doctors and patients alike to realize that once you've acquired disease, if it takes a lot of energy to prevent a disease, how much more energy do you think it takes to actually cure yourself of the disease? A lot more. So this becomes crucial and very central to helping any patient, whether the disease is an autoimmune disorder, whether it's a chronic infection such as hepatitis, whether we're talking about cancer, whether it's heart disease. It doesn't make any difference. The ability for the body to heal itself of those diseases is dramatically improved and enhanced when you improve the ability for that body to produce energy on a cellular level. So that's it for part one here. You can now go to part two or go to it in another time. The subject we're going to be talking about there is maximizing cellular energy production. So we talked a little bit about how cellular energy production leads to aging and disease, and we talked a little bit about sort of the things that cause that. And so in the next section, we're going to talk about how you can maximize your cellular energy production, what you can do in your life, and what your doctors can do to help you. And doctors, you're going to learn about how to help your patients in a much more efficient way.